The tstats command performs statistical queries similar to the stats command, but accelerates searches by querying tsidx files instead of raw data. Leveraging the tstats command is essential for building optimized dashboards. It is used to search tsidx files created by accelerating a data model, as well as tsidx files created at index time, which is why the tstats command is typically much faster than the stats command. While it is closely related to the stats command and shares many of the same functions, its usage and syntax are a little different. The tstats command is a generating command, which means it must be the first thing in your search following a pipe. The only required argument for tstats is a statistical function, like count or range. However, it can take a number of optional arguments. Let's see tstats in action with an accelerated data model. We can see the data models available to us by selecting Settings and then Data Models. We have an accelerated data model titled Web Sales. We can tell it is accelerated by the yellow lightning bolt. To see what fields it includes, we click the Pivot button and select the Information dropdown next to the Purchases root object. We see that it contains a limited number of fields, including product name and price. Returning to the Data Models Management page and selecting the Information dropdown for our data model, we see some details about it. Items under Acceleration let us know the current status and details of the acceleration. Clicking Configuration Settings, we see that this data model is accelerated over the last 4 months. We will use this data model to create a visualization displaying the sum of products sold online by product name split by day. We begin the search with a pipe, then use the tstats command. Like stats, tstats requires at least one function to work. We use the sum function with the price field from the purchases object inside the data model. To search our data model, we use a from clause with the name of the data model. We want to show results in one-day buckets of time, so we split by time and product name, with a span of 1 day. In the time range picker, we select a time range for the last 2 months. Upon running the search, results are quickly returned. As you can see, Splunk returned the data we wanted, but using it with a line chart visualization causes some issues. We pipe to a time chart command with a span of 1 day, and sum of the price field from our data model by the product name. When we run the search, we get nothing. This is something to be aware of when using tstats. If you need to pipe your results into a stats, chart, or time chart command, you need to use the pre-stats argument. We add pre-stats with a value of true to our search. Running the search now results with the correct values and the expected visualization. This search is well within the accelerated 4-month time range. If a search is run outside of the time range, Splunk will revert to its full search behavior to retrieve the additional data. If you have accelerated a data model, there is a pretty good chance that you did it to limit searches to the accelerated time range. Using the summaries only argument with a value of true will limit the results returned to only data summarized in the data model's tsidx files. When we add the argument to our search and select a time range outside of our acceleration, only data included in the tsidx files is returned. In addition to the from clause we used earlier, tstats has other optional clause arguments like where and by. Where is used as a filter, allowing you to specify either a search or a field and a set of values with the in operator. Whereas the by clause can provide any number of group by fields, which will allow you to further organize the data returned. We have explored a couple of optional arguments for the tstats command here, but for a more comprehensive look, I've added a link to your notes.